Hello and welcome to the Spring Board Algebra 2 Lesson 31-1 tutorial. My name is Mr. Yeselyurt and I'll be helping you with some problems about radian measure and specifically arc length. So in this video we're going to be talking about arc length. As you can see here, here's a circle. If you have a radius, a radius of r, and you open up an arc like this, you end up getting an arc length, which is s. Now s is a fraction of the total circumference, so we're going to talk about that in a bit. Let me also mention that that angle of opening there is called x. We're going to call it x degrees. And what we're going to do is calculate the arc length s for different values of x degrees. We'll just leave r as r for a general radius. So what I did is I made a table. We're going to calculate it for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and also 90 degrees. And you can see in each of those, in the fraction area, I wrote down some pictures. I drew some pictures of what the arc would look like. And so here's the idea. We're going to take the fraction of the circle, we're going to multiply it with the circumference, and we're going to get the arc length that results. The reason for this is that if you look back at the circle picture, this arc length is just a fraction of the total circumference around the circle. So it would make sense then to find what fraction this is and multiply that with the total circumference to get the arc length. And this is what we do here. So it's color-coded. Blue is the fraction of the circle. We're going to multiply that with the green circumference, and then we're going to get the arc length. So let me start by doing the fraction of the circle for 0 degrees. Now if it's 0 degrees, there is no opening. So the fraction is 0 over 360, which is 0. Okay? And the circumference is always 2 pi r. Now when I multiply them together, I'm going to get 0 times 2 pi r, which is going to be 0. So the arc length is 0 when it's 0 degrees opening. That makes sense. So let's now do it for 30 degrees. For a 30-degree opening, it's going to be 30 over 360, which is 1/12. And once again, the circumference is 2 pi r. So the arc length is going to be 1/12 times 2 pi r, which is going to be pi times r over 6. That's the arc length when there's 30 degrees of an opening. So as you can see, this is the pattern we're doing. We're finding the fraction, multiplying it with the circumference, and then getting the arc length. So I'm going to quickly go through the rest of these. 45 over 360 is 1/8. And I'm just going to write 2 pi r for all of these because that's what it is. Okay. And then for the arc length, it's going to be 1/8 for 45 degrees. 1/8 times 2 pi r equals pi r over 4. And for 60 degrees, it's going to be 60 over 360. That's 1/6. Multiply that with 2r. I get 1/6 times 2 pi r, and I get pi r over 3. And then last but not least, in this list, we get 90 over 360 is 1/4. And then we multiply 1/4 with 2 pi r. And then we get pi r over 2. So the purpose of this exercise was to show you how arc length is calculated. Now what I'm going to do is write a general rule or formula for arc length. So we're just going to paste this thing into here. So I'll write that down here. Arc length s is equal to the fraction, which is x over 360 degrees, where x is also in degrees, like that. And times the circumference. So it's going to be times 2 pi r. So this is our formula for arc length. Okay, this is the fraction part, this x over 360, and 2 pi r is the circumference. Okay, So what if we had a problem where we were given the radius being 10 feet and x was 90 degrees, and we were asked to find what the arc length s is of that arc? So this is what we're trying to find. Well, we would just plug it into the formula, but remember that that formula actually means the fraction, which is 90 degrees divided by 360, times the circumference, which is 2 pi times 10 feet. So I get 1/4 times 20 pi feet, okay, which is equal to 5 pi feet. And remember that pi is 3.14 roughly, so we're going to use 3.14 as a value. And when I plug this into the calculator, I get 15.7. So the arc is 15.7 feet long. That's what it's saying. The arc length, that S, is 15.7 feet long, which happens to be 1/4 of the total circumference, right? That's what this 1/4 means right here. Okay, so now let's go down to another problem. This one is a little bit more involved, but it's okay. So we're told that we have a BMX bike wheel, and this bike wheel has 36 spokes. And the wheel is 28 inches in diameter, so this might be like the rim of the wheel, and these are the spokes of the wheel. So the question is asking us, how many degrees are there between each spoke? Like in this opening here, what is that angle? And what is the length of the wheel edge between each spoke? So let's do how many degrees between each spoke first. So because there are 36 spokes, we're going to take the total interior angle of the circle, which is 360 degrees, and we're going to divide it by 36 spokes. So we get 10 degrees. So this is 36 spokes. We get 10 degrees per spoke. And a spoke is, in case you don't know, it's one of these radial pieces of metal that hold the wheel, that give the wheel its strength. So if it's 10 degrees per spoke, that means if this is the center of the wheel, we have something like this, where this is 10 degrees. Okay, and this is the edge. And this is one spoke, that's the next spoke. So the next thing that we are asked to find is, what is the length of the wheel edge between the spoke? In other words, what is this arc length? I'm trying to find that. That's the length of wheel edge between each spoke. So what we'll do is go back to our formula, which is S equals x degrees over 360 times 2 pi r. Now, do we know what x is? Yes, we do. X is 10 degrees. This is our x. So I'm going to write that right here. 10 degrees divided by 360 times 2 pi. Now, do we know what r is? We do, but not yet. We need to find it. So they told us that the wheel is 28 inches in diameter. Remember that in a circle like this, the diameter is this. So if the diameter is 28, then half of it is the radius. So that means it must be 14. So the radius is 14 inches. Now what I'm going to do is plug this into the calculator, and I'm going to input the value for pi as 3.14, or use the pi key. So since the calculator has a pi key, I'm going to use it. And I get, what do I get? Let's see. I get 2.44 inches. So 2.44 inches, that means that this thing right here, this arc length, is 2.44 inches. So our answer to our first one was that it was 10 degrees per spoke, and for part B, it was that the arc length is 2.44 inches between each spoke. Each spoke on the rim. The rim being the outer part right here. Okay, so that's it for this video. There's a second part for lesson 31-1 that I'm going to go over, where we convert angles into radians. So from degrees to radians. So stay tuned.